Hi, welcome back to my class in Integral Calculus. For today, we will have one more example for integration by partial fraction case 1, and then we will proceed with integration by partial fraction case 2, where the factors of the denominator of the rational expression in the integrand of the given integral are linear factors, but some of the factors are repeated. In integration by partial fraction case 1, the factors of the denominator of the rational expression in the integrand of the given integral are linear factors, but all of them are different or unique. None of the linear factors is repeated. For our one more example for integration by partial fraction case 1, consider the following integral. We have the integral of x raised to 4 minus x cubed minus 14x squared plus 26x minus 1 all over x cubed minus x squared minus 14x plus 24. And we integrate with respect to the variable x. Now, you know that you will use integration by partial fraction because the given is a rational expression. The given integrand is a rational expression. But for this particular example, the highest exponent of the variable x in the numerator of the rational expression is 4, and the highest exponent of the same variable x in the denominator of the rational expression in the integrand is 3. If the highest exponent of the variable in the numerator is greater than the highest exponent of the same variable in the denominator, you should divide first the numerator by the denominator. So we will do that. We divide x4 minus x cubed minus 14x squared plus 26x minus 1. We divide by x cubed minus x squared minus 14x plus 24. And we apply what we learned from algebra, division of algebraic expression. We divide x to the 4 by x cubed. X raised to 4 divided by x cubed is x. And we multiply each term of the divisor by x. X multiplied by x cubed is x raised to 4. X multiplied by negative x squared is negative x cubed. X multiplied by negative 14x is negative 14x squared. And x multiplied by 24 is 24x. Now we do subtraction of algebraic expression. X to the 4 minus x to the 4 is 0. Minus x cubed minus the same quantity, negative x cubed is 0. Minus 14x squared minus the same quantity, negative 14x squared is 0. So this first term is cancelled, second term is cancelled, third term is cancelled. Next, we have 26x minus 24x is 2x. And we bring down the last term, a constant term, negative 1. Since we cannot divide 2x by x cubed, we are done with the division. And this rational expression can be written as x, the quotient, plus the remainder 2x minus 1 over the divisor. We write the rational expression as x plus the remainder to x minus 1 divided by the divisor, and we integrate with respect to x. And by one of the integration rules, the integral of a sum is equal to the sum of the integrals. This is now equal to the integral of x with respect to x plus the integral of this rational expression. Plus the integral of this rational expression to x minus 1 over x cubed minus x squared minus 14x plus 24. And we integrate with respect to x. It is in this second term that we apply integration by partial fraction. And the first step is to factor the denominator of this rational expression to x minus 1 over this polynomial expression x cubed minus x squared minus 14x plus 24. And we will, to factor out this polynomial expression, we will use synthetic division. We take the coefficients of the terms. In the first term, coefficient is 1. Second term, coefficient is negative 1. Third term, coefficient is negative 14. And the constant term is 24. What we will actually do here is to find the roots of the cubic equation x cubed minus x squared minus 14x plus 24 equals 0. Again, we take the coefficients of the terms and the constant term. Coefficient of the first term is 1. Coefficient of the second term is negative 1. Coefficient of the third term is negative 14. And the constant term is 24. The possible roots of this cubic equation, when equated to 0, are divisors of the constant terms. And what are the numbers that divide 24? We have 24, positive 1, negative 24, negative 1. 12 is a divisor of 24, as well as negative 12. 4, plus and minus 4 are divisors of 24. Plus and minus 6 are divisors of 24, plus and minus 3 are also divisors of 24, and plus and minus 8 are divisors of 24. So there are many possible roots for this cubic equation. And I will try first x equals 3. By synthetic division, bring down the first coefficient, 1, and always bring down the first coefficient. Whatever is this number, you bring it down. Multiply this number by 3. We have 1 multiplied by 3 is 3, and you write it here. And you add negative 1 plus 3 is 2. And multiply 2 by 3. You get 6, you write 6 under negative 14. And you add negative 14 plus 6 is 8. Negative 8. Negative 14 plus 6 is negative 8. Negative 8 multiplied by 3 is negative 24. And you add 24 plus negative 24 is 0. If you get 0 as the last number, that means x equals 3 is a correct root. That means 3 is a root of this cubic equation. When you equate this polynomial expression to 0, 3 is a root because we get a 0 in the last number. But if you do not get 0 in the last number, that means 3 is not a root. So you have to try another divisor of the constant term 24. Since we get 0 here, x equals 3 is a root. And for this root, the factor of this polynomial expression is x minus 3. You transpose 3 to the left hand side, you have x minus 3. So this rational expression 2x minus 1 over x cubed we will write this rational expression as 2x minus 1 over the factors of this polynomial expression or cubic expression. And because the highest exponent is 3, that means there are 3 factors. And we find the other factors by continuing the synthetic division. Another factor now is a divisor of negative 8. And what are the numbers that divide negative 8? You have plus and minus 8, plus and minus 1. Plus and minus 2 are divisors of negative 8, and plus and minus 4 are divisors of negative 8. Now I will try 2. Again, bring down the first number, 1. And multiply 1 by 2. 1 times 2 is 2, and you write it here. Add 2 plus 2 is 4. And multiply 4 by 2, you get positive 8. And minus 8 plus 8 is 0. Again, we get a sum of 0. The last number we get is 0. That means x equals 2 is a root of this cubic equation if you equate this cubic expression to 0. X equals 2 is a root, which means that x minus 2, you transpose positive 2 to the left, you get x minus 2 is a factor. X minus 2 is a factor of this cubic expression. Now, if you have only 2 numbers left in the last line, and the first number is 1, that means the third root is 4. Or you continue with the process of synthetic division. The possible value of x are divisors of 4, and those are plus and minus 4 and plus and minus 1. And I will use minus 4. Again, bring down the first number and multiply that by negative 4. 1 times negative 4 is negative 4. And you add 4 plus negative 4 is 0. So the last digit here is 0. That means x equals negative 4 is a root of this cubic equation if you equate this cubic expression to 0. Or equivalently, x plus 4, if you transpose negative 4 to the left hand side, you get x plus 4 is a factor. And the third and last factor x plus 4 is the third and last factor of this cubic expression. Hence, this rational expression is equal to 2x minus 1 over these three linear factors of this cubic expression. Now you can see all the factors are linear because the exponent of x in each of these factor is 1, and all the linear factors are different or unique. That means we will apply integration by partial fraction case 1. And we will now write this rational expression as a sum of partial fraction. Write the rational expression 2x minus 1 over x cubed minus x squared minus 14x plus 24 as a sum of partial fractions. And earlier we obtained the factors of this cubic expression x cubed minus x squared minus 14x plus 24. And the factors are x minus 3, x minus 2, x plus 4. Since the factors are all linear factors and they are all different, we apply integration by partial fraction case 1. And since we have three linear factors, we need three constants denoted by a, b, c. Hence, this rational expression as a sum of partial fractions is equal or is equivalent to a over the first linear factor x minus 3 plus the second constant b over the second linear factor x minus 2 plus the third constant c over the third linear factor x plus 4. And we will find the constants a, b, c so that this rational expression is equal to the sum of partial fractions. First, we eliminate the denominators by multiplying both sides of this expression by x minus 3, x minus 2, and x plus 4. Multiply the left hand side by x minus 3, x minus 2, and x plus 4. And this product will cancel out with this product in the denominator because they are the same quantity. And we are left with 2x minus 1 at the left hand side. Identically equal to, we multiply this first term a over x minus 3 by x minus 3, x minus 2, x plus 4. If you multiply this by a over x minus 3 in the denominator will cancel out with x minus 3 in the numerator. And we are left with a multiplied by x minus 2 multiplied by x plus 4. Now we multiply the second term b over x minus 2 by x minus 3, x minus 2, and x plus 4. If you multiply these factors by the second term, x minus 2 in the denominator will cancel out with x minus 2 in the numerator. And we are left with b times x minus 3 times x plus 4. And finally, the last term c over x plus 4, we multiply by x minus 3, x minus 2, and x plus 4. If you multiply these factors with the last term c over x plus 4 in the denominator will cancel out with x plus 4 in the numerator, and we are left with c times x minus 3 times x minus 2. After removing the denominators, we now remove the grouping symbols by performing multiplication. We multiply x minus 2 and x plus 4. The left hand side is the same, 2x minus 1. Multiply x minus 2 and x plus 4 and you will get quadratic expression. X times x is x squared. We have minus 2x plus 4x is 2x. And the constant term is minus 2 times positive 4 is minus 8. Multiply x minus 3 and x plus 4, you will get another quadratic expression. X times x is x squared. Minus 3x plus 4x is x. And minus 3 by 4 is negative 12. Multiply again, x minus 3 times x minus 2, x times x is x squared. And minus 3 times x is minus 3x. Minus 2 times 2 is negative 2x. Minus 3x is negative 5x. And the constant term is negative 3 multiplied by negative 2 is positive 6. Now we collect all the like terms at the right hand side. The left hand side is as is 2x minus 1. Identically equal to, we start with the terms with x squared. We have a times x squared is ax squared. B times x squared is bx squared. And the last term with x squared is c multiplied by x squared is cx squared. Now we collect all the terms with x. A times 2x is 2ax. Plus b times x is bx. And c, positive c times negative 5x is negative 5cx. And collect the constant terms, the terms without the variable x. We have a times minus 8 is minus 8a. We have b times negative 12 is negative 12b. And c times 6 is 6c. And we factor the common factor in each group at the right hand side. For this group, the common factor is x squared. And the other factor is a plus b plus c. In the second group of like terms, the common factor is x. So factor out x from each of these three terms, and you will get 2a plus b minus 5c. Multiply by the common factor x, and the last term has no common factor. It is there is a common factor, but the common factor is a constant too. And if the common factor is a constant, simply a constant, do not factor it out anymore, because a constant negative 2 multiplied by the other factor, which also a constant, is again another constant. So we'll take this as is plus minus 8a. And the left hand side is as is 2x minus 1. Now we equate the coefficients of the variable at the right hand side with the coefficients of the variable at the left hand side. The coefficient of x squared at the right hand side is a plus b plus c. and we equate that with the coefficient of x squared at the left hand side. But the left hand side has no x squared. But if you will add a term to the left hand side with x squared, its coefficient must be 0. You can add 0x squared to the left hand side, and this simplifies to the same expression, 2x minus 1. We add 0x squared, so you can see that this coefficient of x squared, a plus b plus c, is equated to the coefficient of x squared at the left hand side, which is 0. So we equate a plus b plus c to 0. And the coefficient of x at the right hand side, 2a plus b minus 5c, we equate to the coefficient of x at the left hand side, 2. We write 2a plus b minus 5c equals 2. And the constant term minus 8a minus 12b plus 6c, we equate to the constant term at the left hand side, negative 1. We write minus 8a minus 12b equals, this is the constant at the right hand side, and we equate it to the constant at the left hand side, negative 1. Now we have generated a system of linear equations in 3 variables a, b, c. And we will solve for the values of a, b, c from this system of linear equations in 3 variables a, b, c. And this is where you will find your skills in solving system of linear equations by algebraic elimination, very useful. Now I will eliminate b from equations 1 and 2. By subtraction, because b have the same coefficient of 1. So b minus b will be 0. We have a minus 2a is minus a. And b minus b is 0. And c minus negative 5c is the same as c plus 5c or 6c. And 0 minus 2 is negative 2. Again, I eliminate the variable b by subtraction. We subtract equation 2 from equation 1. Or a minus 2a is minus a. B minus b is 0. 5 minus negative 5c is equal to c plus 5c. We get 6c. At the left hand side, 0 minus 2 is negative 2. Now, we need another equation with variables a and c. So, I will eliminate b from using equation 1 and equation 3. To eliminate b from equation 1 and equation 3, we must make the coefficient of b numerically the same as the coefficient of b in equation 3. In equation 3, the coefficient of b is minus 12. I will multiply equation 1 by 12 so that the coefficient of b will be positive 12. And we add equation 1, we eliminate b by addition. If b will have a coefficient of 12 and b in equation 3 has a coefficient of negative 12, and we can eliminate b from equations 1 and 3 by addition. But first, we multiply equation 1 by positive 12. We have 12a plus 12b plus 12c equals 0. And to this equation, we add equation 3 minus 8a eliminate b by addition because the coefficients of b in the two equations are numerically the same 12 but opposite in sign. So we eliminate the variable b by addition. Minus 12a plus minus 8a, or 12a minus 8a is 4a. And 12b minus 12b, or 12b plus negative 12b is 0. And 12 plus 6c is 18c. We are eliminating b by addition. 12a plus negative 8a is 4a. 12b plus negative 12b is 0. 12c plus 6c is 18c. At the left hand side we have 0 plus negative 1 is negative 1. So the second equation with variables a and b, 4a plus 18c equals negative 1. Now we have reduced the system of linear equations in 3 variables to a system of linear equations with only 2 variables now, a and c. And we will solve for the values of one of the 2 variables in this system of linear equations. I will eliminate a from these equations by multiplying minus a plus 6c equals negative 2 by 4. So that the coefficient of a in this equation will be negative 4. And the coefficient of a in this equation is positive 4. And we can eliminate a by addition. Multiply this equation by negative 4. We have negative, I will use positive 4. Because we will eliminate a by addition. The coefficient of a must be numerically the same but opposite in sign, one positive and one negative. So we multiply this equation by positive 4. Multiply by minus a, negative 4a. 6 multiplied by 4 is 24c. And negative 2 multiplied by 4 is minus 8. To this equation, we add the second equation, 4a plus 18c. Equals negative 1. And we eliminate a by addition because the coefficient of a in the 2 equations are numerically the same 4 but opposite in signs. One is positive and the other is negative. So if you add negative 4 plus positive 4a, you get 0. 24c plus 18c, you get 42c. And minus 8 plus negative 1 is negative 9. Finally, to solve for the value of c, we divide both sides of this last equation by 42. 42c divided by 42 is c. And negative 9 divided by 42 is negative 9 over 42. And that is the value of c, negative 9 over 42. With that value of c, we can solve for the value of a from this equation, minus 8 plus 6c equals negative 2 by replacing c with negative 9 over 42. Or you can solve for c from this equation, 4a plus 18c equals negative 1 by replacing c with negative 9 over 42. And after you have solved for a and you have a value for c, you can solve for b by using any of these three equations. Now solve for a. From this equation, minus a plus 6c equals negative 2. I will transpose negative a to the other side, so it becomes positive a. And I will transpose negative 2 to the left-hand side. And the left-hand side becomes 6c plus 2. Therefore, a is equal to 6c plus 2. Again, as I said earlier, I will solve for the value of a from this equation, minus a plus 6c equals negative 2. And I solve for a from this equation. We transpose negative a to the other side, we get positive a. And we transpose negative 2 to the left-hand side, you get plus 2. 6c transpose negative 2 plus 2. And we substitute the value of c into this equation. We have 6 times c is negative 9 over 42, plus 2. But 42 is divisible by 6, so we divide 6 by 6 is 1. And 42 divided by 6 is 7. Therefore, we have negative 9 over 7 plus 2. To get a common denominator of 7, we multiply 2 by 7 over 7. We have negative 9 over 7. To get a common denominator of 7, we multiply 2 by 7 over 7. Common denominator now is 7. 2 multiplied by 7 is 14. Minus 9 is 5. Again, multiply 2 by 7 over 7. Now, we will have common denominator of 7. 2 multiplied by 7 over 7 is 14 over 7. Minus 9 over 7. And 14 minus 9 is 5. 14 minus 9 is positive 5. Common denominator is 7. Thus, the value of a is 5 over 7. Finally, we solve for the value of b. And I will solve for b from equation 1. We transpose a and c to the right-hand side. We have b equals minus a. Transpose c to the right, minus c. And we substitute the values of a and c into this equation. We have minus a is 5 over 7. Minus c. C is negative 9 over 42. Multiply by negative, that's positive 9 over 42. Actually, this 9 over 42 can be reduced to lowest terms because 9 and 42 have common divisor of 3. If you divide 9 by 3, you get negative 3. And divide 42 by 3, you get 14. So you can use negative 3 over 14 as the value of c. I will use now negative 3 over 14. Multiply by negative, that's positive 3 over 14. For us to have a common denominator of 14, we multiply negative 5 over 7 by 2 over 2. Multiply by negative 5 by 2, that's negative 10. Multiply 7 by 2, that's 14. And we have 14 in the second fraction in the denominator. So common denominator is 14. And the numerator, multiply negative 5 by 2, negative 10. Plus 3 is negative 7. And negative 7 over 14 to the lowest term is negative 1/2. We now have found the values of A, B, C. A is 5 over 7. B is 1/2. And I will use the value of C in lowest terms, negative 3 over 14. We substitute these values of A, B, C into this equation. We now replace A with 5 over 7. And we replace B with negative 1/2. And C is negative 3 over 14. Hence this rational expression, which is equal to this rational expression, except that the denominator is in factored form, is now equal to, we now remove this equivalence symbol and we use the equal sign. This rational expression is equal to the sum of these partial fractions. We now integrate both sides with respect to x to get the value of this second integral. We integrate both sides of this equation with respect to x. The left hand side we integrate with respect to x, and the right hand side we integrate with respect to x. And to the right hand side we apply the integration rule. The integral of a sum or difference is equal to the sum or difference of the integrals. And the left hand side is equal to the integral we now write x minus 3 times x minus 2 times x plus 4 as x cubed minus x squared minus 14x plus 24. This cubic expression is equal to the product of these linear factors. And we now bring this back to its original cubic expression. At the right hand side, we get the integral of each term, but 5 over 7, 1/2, and 3 over 14 are constants, and we apply another integration rule that says the integral of a constant times a function is equal to the constant times the integral of the function. So we take this constant out of the integral sign. We write 5 over 7 times the integral of 1 over x minus 3 with respect to x. And the second term minus the constant 1/2 times the integral of 1 over x minus 2 with respect to x. The last term is minus the constant 3 over 14 times the integral of dx over x plus 4. Now using one of the integration rules that says the integral of du over u is equal to ln u. The integral of the first term is 5 over 7 times ln of x minus 3. If the coefficient of x here is not 1, you have to make use of the substitution by letting u equals this linear factor with the coefficient of x not equal to 1. But in each of these integrals, the coefficient of x is 1. So the integral of dx over x minus 2 is ln of x minus 2. And the integral of the second term is negative 1/2 or minus 1/2 times ln of x minus 2. And because this is linear, to make sure that x minus 3 or x minus 2 is positive, we write the absolute value notation. And the last term is negative 3 over 14 times ln of x plus 4. And this is the integral of the second term. Hence, the integral now of the given is equal to the integral of x, which is by power rule, x squared over 2. Plus the integral of the second term, which is equal to 5 over 7 We now write the final answer, the given integral of x raised to 4 minus x cubed minus 14x squared plus 26x minus 1 all over x cubed minus x squared minus 14x plus 24 with respect to x is equal to x squared over 2. X squared over 2 is the integral of x. By power rule, the exponent of x is 1 plus 1 is 2. X squared divided by 2 plus the integral of the second term by partial fraction case 1 is equal to 5 over 7 positive, plus 5 over 7 ln of x minus 3 minus 1 half ln of x minus 2 minus 3 over 14 ln of x plus 4. And since we are done with integrating all these terms, we now write the constant term of the integration. Now you notice that in this example, we did not write c as ln of c, but you have the option of writing c as ln of c, and we apply the property of natural logarithms to simplify, to combine the second, the third, the fourth, and ln c into one expression. But you can give the answer in this form since the first term x squared over 2 cannot be combined with the other terms because x squared over 2 has no ln. And so we write c as simply c instead of ln of c. For your practice, please try the following exercises. Number 1, we have the integral of x raised to 4 plus 2x cubed minus 5x squared minus 7x minus 3 all over x cubed plus 2x squared minus 5x minus 6, and integrate with respect to x. Number 2, we are given the integral of x raised to 4 minus 70x squared plus 121x plus 189 all over x cubed minus x squared minus 69x plus 189, and we integrate with respect to x. For each of these problems, you divide first the numerator by the denominator. And you do that if the coefficient of the variable in the numerator is greater than the coefficient of the same variable in the denominator. And after dividing, you apply integration by partial fraction case 1 by factoring out the denominator into linear factors that are all different. In the next lesson, we will continue with integration by partial fraction, where the factors of the denominator in the given rational expression in the integrand of the given integral are linear factors, but some of the factors are repeated. And that completes our lesson for today. If you have questions about the lesson today, you ask your questions in the comments below. But don't forget to subscribe to my YouTube channel, Art Calisson, the channel of learning and leisure. You may also ask your friends, your classmates, relatives, and neighbors to subscribe to my YouTube channel so they may learn as well. Thank you for joining me in my class today in Integral Calculus.